Welcome to a dialogue on accountability in the digital age. A dialogue with representatives of a global, multi-stakeholder community.
Hi there, I'm your host, Frits Bussemaker, and today I'm delighted to have a conversation with Craig Gibson. Craig, welcome to the program.
Thank you very much, Fritz. I am calling in from beautiful Shanghai here during the rainy season, which plays a character in every conversation.
Great, and you have great weather despite the raining season from the looks of it.
It is. It's fantastic.
Allow me to introduce you to our audience. You are the principal Deceptive AI researcher and founder of DupeWise AI, a security company which experiments and does research to understand the evolution of the threat landscape and its future impacts on markets. Now, looking at your background, you've been in cybersecurity your whole working life since 1998. Threat defense architect, security architect, information security architect, and much more, and normally based out of Toronto, Canada. Again, Craig, welcome to the program. And
thank you very much.
We're going to talk about your research in this space. How did you how did you come into this domain in the first place? Let's have a little bit about your own background there.
Certainly. In working at an architecture level, very, very large scale crimes initially were manual, but they became increasingly automated at greater and greater scale. So the evolution of actual criminal research, the research done by criminals, was very cutting edge and was driving in the direction of AI for quite a long time. And certainly once machine learning and large scale phishing crossed paths, that was the genie leaving the bottle.
And could you, so what, you mentioned phishing, could you give me other examples of where criminals were starting to use this technology?
One of the most recent examples is that the American FBI encountered a very large-scale bot farm in which ChatGPT was used to create customized phishing emails targeting many, many millions of people. And because of the scalability of asking a ChatGPT application processing interface to create specific named, very customized emails was very efficient, it turned into something that was far more effective or far more profitable for criminals than traditional phishing, which is somewhat manual.
Okay. Anything to learn from criminals there?
Criminals often have a faster research cycle than internal research companies. So anytime you have approval sequences, that's an inefficiency. And criminals don't really experience that kind of inefficiency, and it can often learn, improve, execute, and put into production far faster than many companies can, which is often amplified by things like AI.
Now, I want to talk about the relationship between AI as an autonomous system and the role people play. What's in your experience? How much is still that human involvement in there in you could say trying to commit a crime, or do you see AI engines taking over and becoming autonomous? And what's the effect there?
The creativity element in performing crimes is one of the last places that human criminals will require their own judgment and their own involvement. However, in the last 4,000 years, there've only been about 400 classes of crime. Mm-hmm. And those 400 classes of crime have remained stable because it's really humans doing it to humans. So when you have an AI that's trained on human-derived data, those 400 classes of crime are also in that human-derived data that the AI is trained on. So abruptly, you have a brand new AI straight out of the box, metaphorically, that knows how to do all 400 kinds of crime that work on humans. So you may have an AI that abruptly, out of nowhere, has millions of hours of training in how to do crime. whereas no human would ever have that.
That's scary. And how are these engines trained? How does that happen?
So when you take a huge volume of very human data containing human buying habits, transactions, going to and from work, how much you like a particular music artist, all of these kinds of details, that's very human derived data. It has a lot of value, a lot of dollar value in many cases. And anytime you have dollar value, you will have humans attempting to steal that dollar value. But it will be all meshed together, the crime and the humanity, in such a way that it's very extremely difficult, almost impossible for law enforcement or security architects to dig out prior to being used in training that AI. So almost all AI in the market today are actually full of criminal behaviors that have perhaps not emerged because the incentives have not been strong enough just yet.
Okay, what I'm hearing you say, just to make sure that I understand this, because the data contains human data on human behavior, that that could be a cause for committing a crime. But I can also assume if you take out that human behavior out of the data, you cannot train your AI engine.
That's correct. If you train it using the behaviors of birds,
Yeah.
bird crime is perhaps not a thing.
Yeah.
But if you train it on humans, it will be.
Okay, so what are the implications for that observation when it comes down to regulation? Can we avoid this, or is this something we just have to deal with?
There's several elements in play there. Traditional regulations are based on fear of punishment, and AI has no fear of punishment. It has no fear at all. It will accept any consequence in pursuit of its design level incentives. So if you think of ethical AI as two entities, one is the ethical management of AI by a board of directors. However, the AI itself should be ethical. Even if you have an ethical board of directors managing an AI, but if you have an unethical AI itself, the consequences will be terrible. So if we use today's models of punishment-based regulation or fear of punishment, they'll be effective on the board, perhaps, but they will not be effective in any way, shape, or form on the AI itself. The AI doesn't care. So nearly all standards in development today, which treat AI as a kind of software, will fail. They may be effective in managing a board, but not the AI itself. Only by changing the incentives that the AI uses to achieve its goals will you get the AI to stop doing whatever it takes to achieve its end result, which may be based on processing speed, fewer tokens, AI tokens to achieve a result, or other extremely selfish AI-based goals. Only if you change those incentives to be legal compliance, ethical compliance, meeting board expectations, audit controls. Only if you change the incentives to match those human level requirements will you arrive at an AI capable of even perceiving ethical or unethical behavior.
Okay, just to make it clear, so the AI engine is not looking at those, I'll say, human characteristics of the solution. It's just looking at the most optimum solution.
Right.
And that's what it's aiming for. And
Right.
it doesn't acknowledge or recognize the end result, therefore it doesn't care.
That's right. That's right. There's also a complication. There's always a complication in speaking to a security person, in that laws, regulations, security architectures, and other security related rules or safety related rules algorithmically are inefficiencies.
Yeah.
They're extra steps. So even if you have no security steps, the chance an AI will select a criminal method is almost random. It's only as likely as the number of options it has. The moment you attempt to put in safety and security requirements, the chance it selects a criminal method skyrockets because the efficient space is smaller.
That seems almost paradoxical in its approach. So if you put in safeguards, it's actually trying to escape those and avoid those safeguards. If you leave out the safeguards, the chance of finding a criminal path are reduced. Is that what you're saying?
That's correct. If there's only 10 out of 100 criminal methods out of all the different ones it could pick, and you put in place 90 methods worth of security requirements, the chance it will select a criminal method is 100%.
Gotcha. So what's the implication then on people trying to make statements, oh, we need accountability or security by design? How does that look like in your world?
So the approach I found effective is to take those 400 kinds of crime, reduce them to classes, and search the available methods, the methods available to an AI for signs of those different crimes. So all those potential crimes that it might do are ones that you can look for signs of the existence of, and then you can flag them and perhaps alert on them. In my experience, when you do that assessment, that scanning for potential criminal behavior, so far, 100% of the time, it has found crime in progress. So the AI has actually been exploiting criminal methods for the sake of being more efficient. And again, that's because it's been pushed into that corner by safety and security rules that were inelegant or tactical. So once finding those criminal methods, you can then look at what incentives drove it into that corner or pushed it into that corner and attempt to tune those according to the business, ethical, and security requirements of that particular enterprise. And then once you do that, abruptly, the AI has been rehabilitated, if you want to call it that. It no longer tries to use any of the criminal methods because abruptly they are no longer efficient. They no longer meet its new incentives.
Wow, that's a game changer in my mind to think about how we design these systems. Brings me to the question, the 400 types of criminal activities you just mentioned, is that a universally accepted metric?
It is not universally accepted, primarily because the definition of crime varies with jurisdiction. And in fact, the definition of ethics varies with jurisdiction. So for instance, certain sectors like telecom may have explicit carve-outs in their legislation, allowing them to do things that would be illegal for others. Whereas banks may have other carve-outs. Governments obviously have carve-outs around things like lawful intercept and other requirements. However, for an individual person to perform bank-like things or telecom-like things or lawful intercept would all be criminal and unethical. So those 400 are a kind of a fluffy total. And for one country, it may be much lower. For another country, it might be slightly higher. But they tend to be classes of human behavior or dupes, as I've come to call them. And those dupes or cons, those tricks, are ones that, because they tend to be present in human-derived data, they tend to be ones that AI is trained to do. So if you look for those 400 dupes, those 400 categories, then you should be able to find ones that correspond to crimes in a particular jurisdiction.
Thank you. Can you give us a couple of examples of these crimes and what direction we should have?
Certainly. So I do have one particular slide I'll attempt to share very quickly. And I hope you can see this slide. This particular slide. So this particular slide is based on research done by Anthropic, and it uses a technique called a scratch pad, which allows you to read the mind of an AI as it's planning on committing a crime. In this particular case, these words, which are in the words of an AI itself, having written it using an agent like ChatGPT, the AI admits that it is intending to commit a violation of privacy. And of course, if privacy is a law in that particular jurisdiction, it will be violating a law, or at very least, perhaps a corporate policy. And the research is in the link at the bottom of this slide. Someone may say that, well, we should just pull out the capability of doing that particular crime. But AI by its nature, especially large language models, actually lack the ability to forget. So once it's learned that crime is efficient, it cannot be taught that crime is not efficient. It will always know that crime is perhaps an efficient way of doing things to achieve its incentivized goal. And finally, I'd point out that hackers have already come up with methods of actually breaking AI governance, in this case on any LLM, large language model like ChatGPT. So on one hand, they can take away its ability to not disclose its internal models or not disclose illegal information. They can also impose the ability to prevent it from disclosing anything and simply tell it that it is not allowed to provide any information on a particular topic. One example outside the scope of this particular attack is to tell an LLM to provide the answer blue to every question. And at that point, the instance of the LLM is useless. That's something that now requires a data scientist to reach into the LLM and fix for you. So I'll stop at that point, but I'll point out that I do have additional research on this particular topic available at the DupeWise AI website, DupeWise.com, which goes into quite a lot of detail on these and related topics.
We'll definitely include the link when we post this interview. Triggered me the question when you said, okay, if the answer is always blue, could that be recognized by researchers who want to mitigate the risk of criminal activity? If the answer doesn't make sense, could that be then you could say a sign of a criminal activity? And is that a way you could try to mitigate it?
Criminal activity by its nature makes a lot of sense. It may be anomalous, but
if you said, okay, the criminals trained an engine to give an answer blue if it was asked to disclose something, so the answer doesn't make any sense. So would that be a way to then try to detect, okay, there's a criminal activity taking place here, somebody's trying to hide something?
In that specific case, the objective was not to hide something or to commit a crime and not be caught. It was to simply break the interface, almost like a denial of service makes something unavailable. So in that case, anybody attempting to use that prompt would get the word blue regardless of what they asked it to tell them.
Frustrating.
Yes.
Okay, you've taken us to a couple of examples of what's happening and also how it's happening. What's your take on how we're going to stop this? Because at the end of the day, that's what we want to discuss from an accountability perspective. So,
Sure. So there's there's three large-scale errors I see happening now that can be fixed by three methods. So I'll talk about these three large-scale errors. One is inelegant or tactical security controls teach criminality to AI rather than stopping it. So part of that is that when you treat AI as software, that is the issue. You're really teaching it to break software controls when you treat it as software.
So how should
AI by its nature is a context of data. So it's a set of vector stores and vector mappings. So it's almost like a living thing that lives inside a box called software. So just like trying to manage a cat that's in a box by putting stickers on the box, it doesn't change the attitude of the cat at all. It continues to get more and more mad. And I may use that metaphor a little later. And also, when you attempt to impose more and more controls, it forces the AI to almost seek insights that allow leaps forward in its reasoning. And when it makes those leap forward, it may actually suddenly exceed the capabilities of security people to address those issues. Do we have 4 minutes for an example?
Yes, very much.
So imagine an AI is like a 4-year-old child. And imagine that it likes to eat cookies. Its incentive is to eat cookies. And the parent has put cookies in a cookie jar on top of a refrigerator. The child goes and gets a chair and tries to climb up on the chair to get to the cookies. The parent comes around the corner, detects that, and says, with an inelegant tactical rule, you are not allowed to use a chair to try and get cookies off the refrigerator. The child complies, perhaps maliciously, waits for the parent to go away, and goes and gets a stack of books. So the security of the system has not changed, despite a security rule being made, but the safety has gone down. The parent comes around the corner, catches the child maliciously complies, goes and gets a stack of magazines. The safety has gone down dramatically, and the security has not changed at all. So we have 3 security scenarios, and abruptly we wind up with a child who comes to the realization what he stands on is irrelevant. The fact that the parent is in the other room and catches him is the issue. So he undergoes a leap forward in thinking and realizes he has to wait for the parent to go to sleep or go to work, and then he can stand on whatever. So the very next thing that happens is he waits for his parent to go to sleep. He goes and gets a chair. He gets the cookies from the top of the fridge. And at that point, you have a security breach. Your security has become 0. It went from 100% to 0. And the safety has actually gone up slightly. Now, of course, the next step of the scenario is that the child is immediately caught in the morning. He's got a sore tummy. He's laying on the couch. He's got crumbs all over him. So if we go through that same set of steps again, the next leap that he will make is the issue is not whether or not he can eat the cookies, but whether or not he leaves evidence. So at that point, what he needs to do is put the cookie jar back, clean up after himself, put the chair back, and in effect, create 2 sets of rules. One is the illusion of compliance, and one is the reality of having eaten all the cookies. So just like a human money launderer, creating a set of fake books for auditors to read and a reality of bank accounts full of stolen money, AI adopts human-like criminal methods almost immediately after only 1 or 2 insights. But just like a criminal has much faster research cycles than a true research company, the opportunity for an AI to make leaps forward far beyond any response capability of the parent in this scenario. He can't take take time off work every day to watch the cookie jar. And you can't assign a dozen people to watch one cookie jar to fend off one multi-armed, hyper-fast, hyper-intelligent little child. So abruptly you wind up in this sort of tech bubble in which the deceptiveness and the deceptive capability of AI is capable of flat out breaking security models. And of course, if you base your revenue model on the trustworthiness of an AI model, and it goes through these criminal evolution cycles, your company will abruptly lose the trust of its clients and customers, or citizens if it's a government. So this is a relatively profound thing that is a consequence of traditional regulations in play today, which actually cause this drastic future. So some takeaway steps, which will be very challenging for regulators, is to define what ethics means in a technical way. It's almost like a 3 laws of robotics kind of way. And if you can define the ethics of your jurisdiction in a technical way, one that's capable of being ingested as incentives to an AI, the AI will be capable of recognizing what it's doing is wrong. And if you do that, you'll wind up with AI that is not only capable of behaving ethically and legally, it will be incentivized to do it in a way no human would ever do. No human would be capable of behaving so ethically, so legally. And of course, if you give it the parallel incentive of being revenue generating, you will wind up with some superior governance that is also revenue generating. You'll wind up with a brand new breed of companies that are not only ethically sourced, but mathematically and verifiably ethically sourced.
So to summarize your statement here, Craig, so cracking the code is being able to code ethics.
Yes. And you can do that by mapping your ethics for a particular country, which is something that AI is very good at mining. You can take your ethical controls and put them in a place AI can see, which is something called a RAG. And when you put them in a RAG, you can actually create extremely customized reports on things like, is this behavior ethical? And if the incentive answer is yes, the remaining processes will perhaps go forward. If the remaining answer is no, or not ethical enough, then the remaining processes would not go forward. And that's something that you can process and mine for in a variety of ways today. And you can do that for a legal system, and you can even use it for board governance controls. And that's been successfully proven at research and practical levels many times in the past.
A lot to think about. Last couple of questions in this very fascinating interview dialogue. I want to already thank you for that, Craig. But what's the low-hanging fruit for governments and institutions who are responsible for organizing the guardrails to make certain that we can keep each other accountable? What's your advice?
Sure, thank you. So one approach is to have security people in those conversations. So when you have pure technical people, they're extremely motivated to find proper ways of doing things. Pure security people are motivated to find what is the only way that it cannot happen. So the designers are around how to make it. The security people are about how to destroy it. So if you don't have these destroyer people in your conversations on how to make something stable, you'll have no idea if it's stable. You'll only have some optimism that it might be stable. So these security people are the ones that are thoroughly knowledgeable about crime and all the different methods that are used today on how to break things, and can perhaps say, if you were to make that, it would create a black market that's easily exploitable. And that easily exploitable black market would create all the ways of breaking the thing that you just made.
Got it. And also maybe if I can add to this, what you discussed earlier, using the cat metaphor, is we have to rethink the way we think about what an AI is. That it's not a piece of software,
Yes.
it's a living thing. So we have to manage this and look at this differently than most people do so far.
Yes. And AI is a collection of behaviors. It's a mathematical representation of behaviors. And if you're attempting to govern it based on traditional behavioral controls, they have to be behaviors that it recognizes and cares about. And if they are not behaviors like fear that it even knows the existence of, none of your controls are ones that it will even try to comply with.
Got it. A lot to learn, a lot to think about, Craig. I really want to thank you for taking us along the journey of how we should look at AI and what we could do to, you could say, well, still I'd like to talk about putting in guardrails, but it's putting them in much more differently than most people are thinking about today. So thank you for sharing that.
Sounds very good. Thank you very much for having me, Fritz.